Good morning, everyone. My name is Sergey Teplyakov. I'm a principal software engineer at Microsoft, and today we're going to talk about how to make .NET applications even faster. I wrote a book about design patterns. I also blogged quite a bit in a blog called Programming Stuff, and recently in Dissecting the Code. So right now, I'm mostly writing about C# internals and .NET internals, and about performance of .NET and C# and various tips and tricks. I'm also an author of error-prone.net. It's a family of analyzers for making your applications correct and performant. I also used to maintain code contracts library, and I am a big fan of design by contract and code contracts. This is my Twitter handle and my GitHub handle. Okay, let's get started. But today's topic is performance. But why should we care today when the computers are that fast? I guess it's kind of a rhetorical question, since we wasted so much time waiting for an update to finish, waiting our IDE to autocomplete, or the build or the CI pipeline to get things done. And in many cases, applications, it's actually really matters, and it's actually part of functional requirements. So operating system, perf is not a compromise that you can make. The databases, messaging queues, and whatnot. It's also very important for frameworks and libraries. And you might have noticed that every year Stephen Tobe posts a ginormous blog post on about the performance improvements in .NET, and it's like 300 pages. So you can guess that .NET Framework or .NET Core right now is focused on performance quite a lot. And if you write your own library, you don't really sure in which context that library is going to be used. So probably perf is something that is kind of an important thing. And there are some types of applications where perf is like absolutely critical. High frequency trading or e-commerce. So there are like various studies that had shown that just the delay in a few seconds can significantly increase the bounce rate and just the number of people who would leave your site without taking any actions. Networking, the space that I'm working on right now, is something that you cannot compromise the performance as well. The DevTools is another area where people do focus on performance quite a lot. Like your favorite IDE, in every release you probably would see a large section dedicated to perf stuff. And if you look at the set of features in like C# language by itself, you'll notice that the devs are focusing on productivity and on performance a lot. And if you host your application in the cloud, probably your CEO might not be happy to see a huge cloud bill when you posted something, when someone posted about your website on Reddit. So there are like quite a lot of scenarios when the perf is really important, and you better be equipped with like the tools and patterns and approaches how to deal with that. So, but before jump into the code base and fix the perf issue, you need to figure out if you have a perf problem and what the perf problem is. In some cases, it's kind of obvious. So, like if the system runs out of memory, or the system became unavailable because it takes like a lot of time to start, it's such kind of bugs can be filed by the user or by your sister team or whatnot, and it's quite easy to find if you have the perf problems of these kinds. Another option could be like, okay, so you have the dashboard and you can see that now we have a drop in the throughput, or you have a long GC pauses that causes sporadic service and availability errors. Or you can have a user survey, and that might show that the perf is the main factor why people are leaving and to use the competitor instead of using your application. In dev space, it's a huge push right now to reduce the build time, to improve the inner loop, and it's all about performance and productivity. So, and the performance analysis is an extremely data-driven thing. So you can think about this as a like testing pyramid, like where on the top level it's kind of end-to-end tests, and in the bottom are the unit tests. And for perf, you should have the same kind of thing. So you should have a top-level metric that indicates if you have an issue on a very high level, something like your application throughput, the latency of some sort, and whatnot. Then, in order to figure out where exactly you have a problem, it would be nice to have a profiling data from production or from pre-production or from test environment. Something that is like examines your system with real load and shows in which part of the code base or the system you've spent the most time. The next level is kind of like integration type tests for perf. So you might have an integration test that you can kind of like local stress tests that are not really the production load, but somewhat similar. And if you can extrapolate the data that you're getting from those integration tests to production, that would be amazing. In this case, you can profile your application locally, figure out the hotspots, fix them, and then you can have a high confidence that those fixes would represent a perf gains in the production environment. And the lowest level, similar to unit tests in terms of like code quality and correctness, is benchmark results. This is like a very niche and very specific set of test suites that compares a small part of the system, whether it's faster or slower than a similar implementation. So it's a very low level, and similarly to unit tests, when you have a very high unit test coverage but your system breaks in production, you cannot rely only on benchmark results in order to make the perf improvements. You need to get as high level metrics as possible. So here's the workflow that I would suggest people to use in order to fix performance. So you need to figure out the problem. We talked about like a few examples. It might be like, okay, so P90 request processing duration is more than 1 millisecond, and it causes overall system delays. Then you think about this problem and you might come up with a hypothesis of what's wrong. For instance, you can think that, oh, this component or the application allocates quite a bit, and it might be that GC causes sporadic delays because of the GC pauses, and that affects high percentiles of the request processing. You can back this hypothesis with data. So you can check the time in GC background dashboard to see if this is indeed the case. For instance, if time in GC is more than 50%, probably you have a problem, and probably GC slows your application down and affects the throughput in a negative way. But if not, maybe then you would have to think about something else. If the time in GC is really low, like below 10%, probably that's not a problem. So the next step would be to, if possible, to reproduce this issue as locally as possible. So for instance, if you have an end-to-end tests that you can run and measure the GC under the profiler, so you will see that, okay, so this is the longest pause, this is the overall time in GC, and if you have a local repo, it would be quite easy to fine-tune the GC settings and see that those settings indeed causes a increase of throughput. So in this case, for instance, maybe you've noticed that your application still uses workstation GC and the memory traffic is really high. So one of the options is to switch to server GC. And once you switch to server GC, you can rerun your like benchmark or end-to-end test to see that it indeed works, indeed helps the throughput. And then the next step would be to check the code in and validate that indeed this approach and this fix works in dev, PP, and prod environments. Here's an example. So in this case, I went from the problem, and from like the symptoms rather than the from the end-to-end problem, but this clearly indicates the impact and the logic. I noticed that the time in GC for some of our services is quite high, like more than 20%. I ran the local profiling and noticed the same. Time in GC is quite high. The GC pauses are everywhere, and this is timeline view from .trace, and you can see here that these small pauses usually an indication that you have a workstation GC and it just cannot handle the number of allocations. I've made a change. So we deployed the change roughly at whatever, like June the 7th, and at the same time when the GC time in GC dropped, we also noticed the drop in P90 for request processing duration from like 1.5 seconds to like 0.7, so 2 to 3x perf improvement. Okay, so this is the idea, and one very important caveat when you're dealing with perf. This is Kevin, and Kevin is a well-known person in .NET community, and he deals with perf quite a bit. And this is kind of stuff that resonates with me really well, that it's not always a happy ending for your perf optimization journey. For this specific perf fix, you might come up with the solution, you'll optimize the hell out of it, you'll benchmark or profile just to see that your new solution is just slower. So in this case, just take a step back and think about other options, how to fix this problem, and move forward. And overall, like high performance, if your application has a high performance demands, it's not something that can be fixed once and for all. So this is definitely a journey. So the world is changing. The load might be changing for your application or your system. The use cases might evolve. The environment where you run the system might change. The runtimes are changing. And definitely the perf bugs are going to be introduced. And this is something that is really hard to see if this specific thing might affect performance. So in this case, I would suggest to have top level metrics. You might have the alerts on if you'll get a perf regression when the processing rate drops like 2x or whatnot. You might get an alert in test or PPE or even in prod environment. And so in this case, the only option is measure, and measure often and measure a lot. And occasionally profile your application to see if the regression was introduced at some point. Just because, again, just by looking at the code, you cannot see if this specific piece of code is going to be slow, just because you need some runtime characteristics. It might be like in terms of complexity, everything might be fine, but the perf might suck, just because you're using list on a hot path, and now you're having some perf issues. And here are some guidelines for like what I would suggest to do in pull requests that intend to fix the perf. So again, as with like our workflow, just start with the problem. So in this case, you need to indicate that the work is not a waste of time, and you don't want to waste the time for the reviewers as well. So that you need to indicate that you're solving the real problem, that there are some metrics, some bug reports, or something that indicates that you do have a problem. So, and explain the issue that you think what causes the perf problem. The reason for that is obvious. Your solution explains what you've done, but not necessarily what assumption you had during the implementation. And it's possible that your teammate might see another option to fix this problem. So usually explaining the context especially in complicated or in a tricky PR is very important. And then show the impact of the change. Use top-level metric if possible. At least show the benchmark results to see that the new version of the code, which is probably more complex and harder to understand, worth it. So, and now we can talk a little bit about like the overall dilemma between performance and maintainability. In some cases, you can get the both. So they're like just better tools and better building blocks. Something like span of t can make your API more elegant and more performant. But overall, I would suggest that in most cases, it's better to focus on readability, maintainability, composability. So something that I value a lot is kind of a mental trick that I use. If I can if it's easy to get rid of the code and make the code deletable, it means that it's indeed loosely coupled. It means that without using strategies and patterns and whatnot, you can go and rewrite this code from the ground up and make it more efficient or whatnot. There are some cases when you really need to focus on perf from the get-go, but in many cases you can squeeze like 2, 3, 5x from your system, even when it was not designed to handle high load, especially with .NET and with .NET Core, with all these low-level tweaks and tricks, you can do quite a lot. So then when you it's easier to start with the system that works and then identify the hotspots, the bottlenecks, and fix them instead of rewriting the whole system. And probably instead of banning Link because of its like well-known bad performance, the simplest solution is to use Link everywhere and then profile and see where it's problematic and get rid of that. Instead of using like one rule to fit them all, it's probably better to focus on the top level, on the like language features and .NET Framework features that gives you the most productivity, and then optimize this when needed. It's definitely way easier to make a good code faster rather than to make a very fast but incorrect code to work correctly. This is for sure the easiest path forward. And just don't overcomplicate the system for no reason. So if you're introducing some even well-known patterns, most of the patterns are intended to be used in some certain contexts, something like object pooling, right? So like to pool objects, it's probably worth doing when the objects are really large and it's kind of collection of some sort. But if the object is 24 bytes, it's definitely not worth it. The GC is really good, and it's highly unlikely that you'll get any benefits, but you'll make the system very complicated because of that. So here's an example when the code might be fast and expressive. As I said, my favorite example is span and span-based code. So this example that I'm showing here with string split, I would say that it's not always, it's kind of almost the same in terms of readability, even though it's like 2.5x more performant. But in many other cases, the span-based API is just plainly better. Instead of having like a lot of overloads, it's just easier to have one overload that would handle like an array of characters, a span of array, list, a string. You just can have a span of characters instead, and that would handle all of that. Another like really good example of the best from both worlds is the new string interpolation feature. It's both more expressive, more extensible, and reasonably more efficient. It's not always easy to get that, but once you get something like that, you definitely would be proud of yourself. Okay, let's think about how to optimize things. And the best way to optimize a thing is to avoid work. What I mean by that, so like this is a chart of the number of operations for one of our backends. And I've spent quite a bit of time to optimize the backend, probably improve the throughput, maybe 2x after like 2 weeks of work. And then we noticed that like, okay, so like we're hitting this backend like a lot, like really a lot. Can we do something with that? And like we've spent some time with the team and figured out the ways how like use some caching in other cases to avoid hitting this because we don't really need to hit that often. In the world, we dropped the throughput by 10x, and that's something that is really hard to achieve by optimizing your backend. And like, as always, you probably heard that like caching is like absolutely crucial for any system performance. This is a way to avoid work, right? Another example, I've created a PR at some point, and so I was looking at some of our like processing pipelines, or processing some XML files or whatnot, and one of the stages was to sort the result. And I was like, okay, so we're sorting using invariant culture. Okay, this is not the best. I can use ordinal. That gives me like 20% better performance. I've created the PR, and after discussing with the team, it's like, oh, but we don't really need to sort the results at all. So it's really hard to beat no sorting with any form of sorting, right? So like bubble sort or quick sort, no sort is definitely the best way, the fastest way. So, and you'll be surprised that in many cases you can do that, in way more cases than you think. The most common performance analysis and fixes approach is to figure out the bottleneck and fix it. I was working on a service that was crashing due to out of memory. And that was a huge service that was taking more than 300 gigabytes of memory. And the startup time was quite high. Like, remember the Bill? Bill who said that like 640K should be enough for everyone? Not anymore. And luckily, we run this stuff in Azure, and we have Azure Profiler running there. This is a kind of a tool that you can schedule when exactly it needs to be run, etc. And when I looked at the data, I noticed that like, oh, wow. So 92% of time is spent in logs, in monitor enter. And from the code itself, it's clear that it comes from string entering. So string entering is kind of like a .NET thing that you can deduplicate the strings. You can call string entering with a custom string, and you'll get the string from the pool. And the old string is going to be collected by the GC. Okay, so during perf analysis, I try to disable that thing completely, again, avoiding work, to see that if it's really needed. And indeed, the string entering was saving like 15% of memory footprint, which is like 45 gigs, which is a lot. And it indeed made the startup time dropped quite significantly. So yes, indeed, it's helpful and it's hurtful. So what can we do? So the way I try just to throwing like a custom concurrent custom string cache, with just a concurrent dictionary that adds this to the cache. As the benefit of this approach is that a global like string table is essentially a memory leak. It's a global table. You cannot clean this up. With a custom, even static concurrent dictionary, some people would complain that like, oh, what about the ICE? Okay, it's fine. It just works. And you can clear at a certain point in time, and you can actually even drop the memory footprint in this case. So I tried to validate that this is indeed the case. First, I wrote a benchmark and got like, whoa, 20x perf differences between string interning and string cache. That was like really surprising. And the funny fact is that I tried like native AOT version, and it was on par with concurrent dictionary, even a little bit faster. And the strangest thing is that in native AOT version of .NET, string interning is implemented in C#, actually. In C#, that is native compiled to a native code. But in full framework or in .NET Core, string interning is implemented in C++, but it's less efficient than just a simple concurrent dictionary. So I measured end-to-end impact. That was like in my test scenario, it gave 20%. The same or even bigger impact was in production environment. Okay, so that was a win. One thing with fixing bottlenecks is that once you fix one set of bottlenecks, you probably would see another set of bottlenecks. And another thing that I want to mention here is that I've mentioned already that perf bugs are really like not equally spread in your code base. In many cases, you can, like in this case, like I've changed 20 files with like a handful of lines of code and got a drastic impact on the startup time. So in many cases, you can find just a few places in the code that might fix a lot of things. As I mentioned already, performance optimization is a journey with one caveat, that the perf fixes are really, really addictive. So you can keep running the profiler and keep finding stuff that you can fix. And even though like you can set a perf goal, but still in some cases the goal's kind of a little bit fuzzy, and you just need to figure out when to stop. And since one hotspot reveals another hotspot, that could be an endless process. And you really need to stop at some point. And first of all, as I said, have a goal. And once you reach it, or if you think that every fix gives you smaller benefits, then you should stop. This is called diminishing returns. Like each new optimization would give you a smaller and smaller impact in terms of end-to-end. So that's why it's important not only to focus on the benchmarks that would continue showing the results, but it's possible that the code that you're benchmarking is just not relevant to the end-to-end scenario and to end user and whatnot. So let's talk about another pattern that I've seen quite a bit. It's called like death by 1,000 cuts. And the idea is that there is like no clear perf problems. So one of the best examples, if you have something with recursion. So for instance, in the build system that I was working before, there was an evaluator, and a common pattern to implement such thing is to use recursive evaluation. So if you need to evaluate a combined expression, like a binary expression, you would evaluate the first operand, then the second one, and then evaluate the sum. And that manifested in a really hard to analyze perf benchmarks. You will see that no.eval takes 90% of time. That calls not.eval, that calls no.eval. At some point you will see that like, okay, you have plus operator somewhere, but it's really, really hard to see where the perf is spent. And each stage takes a little bit of less time, but it's not clear where exactly you're wasting the time. So another good example is method call overhead. And that's the reason why the inlining is one of the most popular tool in our tool belt to fix perf problems. Another thing is like allocations. It's minor, but if you have a lot of them, that could drastically affect the end-to-end performance. Or if you have too many thread running the CPU-intensive work, you might oversubscribe the CPU and you gradually drop the perf. Or like object pooling or property or indexer accessors, they gradually would like waste time here and there, and you won't see where the problem is. And one of the examples that I faced was that once I've implemented that string cache, I decided to use ordinal string comparer. And I've noticed that even though we had like a lot of hash sets of strings and dictionary of strings, we've been using invariant culture. And like, that's strange. I feel that this is not the best approach. And I know that we don't need to have a culture-specific comparison. So, indeed, this is the guideline. Don't use it. So I've created a benchmark to see the results. And, well, I was surprised that ordinal comparer is like 5x faster, like hash set lookups or adding the data to hash set, than invariant culture one. And then I've checked the end-to-end results. And again, your mileage may vary. And in our case, we use the maps and hash sets like a lot. But that gave us 20% startup perf improvement just by switching from ordinal from invariant to ordinal in our case. Okay, so let's move to the next way to figure out the perf problems. This is like, it's interesting that in the latest build talk, Stephen Tobe mentioned the same, that he uses the same approach. He often looks into memory allocations to figure out if you have a perf problem. And this is something that I've been looking almost like my entire perf career, because like any allocations, it means that it's work, and it's really hard to see the waste that your system produces. And allocations, it's kind of the way to figure this out. I constantly look at time in GC because it's a total waste. Instead of doing our work, we're just waiting for the GC to clean up the garbage that your application generated. So, and here's an example. So this is one of the tools that I've been using, I've been optimizing. The idea is that it's again .trace profiler. I love this timeline view because it actually shows both perf and memory at the same time. And this shows that the GC weight was high. The amount of allocations, in this case, it was already after a set of optimization, was 24 gigs. The GC weight was high, and the parse time, the core logic was really high. And the idea was that to optimize the XML processing, we read the files into the file stream, into the memory stream, and then process them. And as always, I try to remove that optimization to figure out if that something that is just a waste of time. Nope, that was useful. Then I've tried a few approaches. I've tried to pass a capacity to memory stream constructor and then to pool memory streams. And here's the results. So this is the original code. It's like a pseudocode. We're using memory stream, opening the file, copying the data to memory stream, and then processing the memory stream. I omit like setting the position to the right to 0. And the original version was allocating 34 gigs of memory in that scenario. And most of that was hitting the large object heap, which is like not fun at all. So then okay, so we can pass the size from the file. The actual logic was more complicated to get the proper error handling and whatnot. And that already dropped the memory allocation by 10 gigs to 24. Okay, cool, that's good. So then I was like, okay, so what else can we do? So I've massaged our pool that we have, object pool, to actually provide a way to create, to construct the instance and to construct not the empty memory stream, but the memory stream with a given size. That shaved another 10 gigs of memory allocations, and overall it dropped like 20% of increased the throughput by 20%, which is quite a lot given the fact that it was like 5 or 10 lines of code change. And here's another example, again, from the real code, but let's look at that. So the idea is that we have a hash set of allowed processes, and we have a list of processes as well. And so I'm just generating a list of processes from A to Z, A.exe to Z.exe, and allowed processes are A.exe, B.exe, and C.exe. And this is the code that counts allowed processes. It's kind of like just an example for that. Looks okay, I guess? If you run this code under the profiler and run this thing like a couple of thousand times, you'll see that, oh, this thing allocates 1 gigabyte of memory, and all of that is enumerator. Like when I noticed the enumerator, it was like, that's strange. I don't think that we need to allocate enumerators here because contains, it should be a hash set contains, and then I looked and like, oh, wait a minute. Okay, this is the benchmark that should be another contains method that contains fast, that uses contains method without passing ordinal. Because when you pass ordinal, this is a link. If you have hash set.contains, it doesn't have this last parameter. So just by, I've added an error-prone rule to detect that, and ran the profiler, the memory footprint dropped, and as you can see from the benchmark results, this is like 3x perf improvement. And again, this code has a asymptotic complexity of n square, or like n O of n, or O of n square. Whereas like we were thinking to have O of n complexity because the hash set lookup should give us a constant lookup time. So, and again, the simplest way to find that was actually to look under the profiler and to see and to notice a huge amount of iterators allocated at runtime. So, and then that was just because the time again for that specific method lookup was spread across other methods and it was not clear to see. So this is another example where looking at memory allocations could be helpful. Again, this is like essentially .trace and timeline view is the only tool that I know that can give you this information, but it's really, really helpful. Okay, so that's almost it for today. And to follow this up, so the perf analysis is really, really data driven. So you just cannot go to the code and mess up with this and figure out what the perf problem is and how to make this stuff faster. Just because it's possible to just change a few lines of code and make a drastic impact on the end-to-end performance. That's why you need to have a top-level metrics. You need to have a tools like profiling tools and whatnot to figure out where the hotspots are and what takes most of the time. And just don't increase the complexity without backing up with data that it's actually worth it. And just focus on simplicity first, and then run a few tools and figure out where the problem is and fix it. And remember that performance fixes are addictive, so just know where to stop. If there is like no end-to-end impact, just stop and move forward to the next thing. You try to optimize another service or figure out other problem to solve. And that's it, and thank you so much. I'll see you on the Q&A session.
Hello. Hi, Sergey. How are you doing today?
I'm doing great, even though it's like almost 1 a.m., but I'm doing great, thank you. What about you?
Yeah, doing great. Okay, so it's late, not early at your time zone. So
Yeah.
I'm checking the Q&A. Somebody is typing in the Discord, so there is going to be a question. But before we get that, Sergey, maybe like the session was great. You're digging into a lot of the details around performance, and you're using a lot of tools, and somehow that was a journey to become an expert in performance. So maybe you could share some advices on how what you can learn and how you can approach that journey of becoming a performance expert.
Okay, so I think one of the main thing how to get there is to get as deep as possible into various domains. So if you look at Stephen Tobe, for instance, it's one of the most famous person in .NET and perf world. He knows a lot about different things, and he can dig deep, really deep. So I would say that I'm writing about stuff. So if I'm facing some challenges, I try to figure out how things work, and probably that helps me to build a better mental model and investigate and understand various performance problems. So I would say dig deeper. So it's like depth of your knowledge and somewhat breadth of your knowledge should help. But just like if you're facing the problem, try to figure out what the root cause is, try to dig as deep as possible. And regarding the tools might help you to identify the problem, but probably a good knowledge of .NET Core, of networking stack, that's something that helps.
Okay, thank you. So we have a few questions here. So Victor is asking, in microservices architecture, how can we effectively monitor and optimize GC performance across multiple services? Are there any specific tools or techniques you could recommend for tracking GC times and memory allocation in a distributed .NET environment? And what are the key metrics and thresholds we should focus on to ensure overall performance in similar microservice environment?
Okay, so I'm not sure that there are like any differences for microservices and whatnot. So time in GC, it's a common metric, and I think with just a few lines of code right now, you can hook this up with like Mirror API in .NET 8, for instance, and you'll be able to export all those metrics and see all the data. In terms of allocations, it's a little bit harder just because tracking the allocations is a more expensive operation. So normally you can, what I would say that track time in GC for each of your services, and maybe get an eye on a service if it takes more than probably. So I would say 10% is or below. It's a normal, like, it's totally fine. Don't look there. If it's 50% or higher, pay attention to that. In between, you might look into this if you have spikes or whatnot, but nothing more than that. But to get exactly what's going on, then preferably to get the tooling, .trace, Visual Studio or something that will give you a more detailed breakdown. I don't think that you can so some stuff like Azure Profiler, for instance, you can configure to get the. So there are some like lightweight analyzers that can, lightweight profilers that can be running on your production environment to measure that. But I'm not sure that microservices or not matters here a lot. So the same technique should be applied for like one box or set of boxes.
Okay, thank you. Then Levka is asking, what is the fast method in count processes? Example in presentation.
Okay,
Are
so
you getting the question?
the fast method was missing. So the idea was that the slow one was using contains with passing string compare, and the fast method was not passing string compare. So meaning that it was using just hash set.contains, and that was a fast version, which is the fixed version for that. I'll fix the presentation, and once I'll share the presentation, it'll be obvious. So not so hashtag contains is fast, link.contains is not fast in terms of in this specific context.
People are typing. Maybe I think we have 1 or 2 minutes. So maybe if as we're talking about count, contains, and the things, can you comment on link? What's your position around link? People are heavily using that. Is it super slow?
Yeah. It's a nice question, and I think many people. I was working on these prefixes, and one of the bottlenecks was about link. And few folks suggested, "Oh, should we ban this?" And my answer was, "No, let's not do that, because it's just a tool, and if this tool can be used correctly or incorrectly, right? And you can use a loop incorrectly. You can do nested loops and do some crazy stuff in loops. But link is a very high level, very expressive tool that can boost your productivity. Plus, link is getting faster and faster in each version. It's like vectorized and whatnot, and you can be really surprised that link can beat like normal loop performance in some cases right now already. And I would say that in order to get perf improvements, you need to measure anyways, regardless of what tools you're using. So it doesn't make sense to sacrifice productivity, because that's the main thing, to get to the end result as reasonably fast as possible, to get as good code and as readable code as possible, and figure out the bottlenecks. And because those bottlenecks might be in link, but might not be in link, and they might be in absolutely unrelated code that you would never think about, it doesn't make sense to sacrifice and stop using such a really productivity booster for you. So don't blame the tool. It's not
Okay,
about
yeah,
that.
that's a relief
It's
to know
about
we're not
us
banning
figuring
link.
out the problem. Yeah,
Okay,
please
thank
don't.
you.
Please, please, please don't.
Okay, Sergey, we have a final question. Can you give any advice on optimizing objects to JSON mappings and DB results to objects mappings in ASP.NET Core API returning huge amounts of data? We have a very simple DB query with a lot of joins that works immediately on the DB side, but looks like DB result to object mapping takes a while, and C# object to JSON mappings take even more. How would you suggest approaching this?
So in this case, I would suggest to profile. So it's possible that, like, obviously those operations that were mentioned, they are using some form of reflection under the hood, right? So and that is slow. So is it possible that those reflection, and it's actually many tools should be using lightweight code generation instead. It should not be actually a reflection, but maybe there are some slow paths in those tools that are causing perf problems. Try to run the profiler to see if it's really bad, because the ASP.NET Core team focused on performance quite a lot. What type of tooling is used, it's not clear to me, and like if it's built in, probably it should have a decent performance. JSON serialization, JSON mapping. So just try to profile to figure out if you're using the tools correctly. It might be not the right tools, but I would say that the DB side should be probably at least as slow as an in-memory thing right now, or even faster than that. So something feels off in this thing. So but yeah, I'm usually using profiler to figure out if something is okay or not. I've been dealing with this, like one of the problems, we were looking at the code that it was slow, and figured out that we were abusing the library that we used there. It was not used correctly. We were not reusing the right objects and whatnot. So as always, file the bugs if you think that it's a bug.
Okay. So we are out of time and we covered all the questions. Sergey, thanks again for a great session.
Awesome.
And we'll forward you the
Thank you so
questions
much.
if there are more on the Discord channel.
Absolutely.
So,
Thank you so much.
I would say,
Thank you for having me,
I
guys.
would say have a good day, but it's actually good night.
Yeah.
Bye
Thank
bye,
you.
Sergey.
And have a great conference, folks.